Okay, so thank you those of you that have green on the left, notes on the right. Okay, so last chapter, we just got done taking a test, right, on expressions. All right, the whole thing was how to simplify expressions. A lot of different skills involved with expressions. Okay, well, what we're going to do now is we're going to go to that other thing, and that is when you have, for example, two expressions, and at times, of course, they have an equal sign in between. So that's actually what we're going to talk about. Is we're getting into a chapter with equations. Right, we talked about the difference between expressions and equations this school year, right? Expressions, I just kind of simplified and said they don't have an equal sign, but an equation does. So that's what we're dealing with, okay? We're dealing with equations. Well, we're going to start off with some of the more simple type of equations, and that is just one step, and we're actually just for today just focusing in on adding and subtracting one-step equations, okay? So we have a nice chunk of vocab, and we're going to be talking about kind of how equations truly work today. We won't go into as much detail tomorrow, but we're going to kind of dive deep into it today. So we do have some vocab words, so stick with me here. All right, our very first vocab word is the word equation. Everyone? Equation. All right, so your book says, here's what your book says. An equation is a mathematical sentence that contains an equal sign. They have an equal sign written there, stating that two quantities are equal. Two quantities are equal. Okay, so in your little box, here's what I want you to put. Here's an example. All right, 3 plus 4 is equal to 6 plus 1. That would be an example of an equation. 3 plus 4 is equal to 6 plus 1. Okay, right next to it, just write the word balance. And that might not make sense right this second, but it will, hopefully, by the time we're done with this lesson. All right? Balance. Okay? Our next word is solution. Everyone?
Solution.
Okay? Here's what your book says about a solution. It says it's a replacement value for the variable in an open sentence. Then it goes on, it says a value for the variable that makes an equation true. Okay? So when you're talking about an equation, it has a variable in it, right? A letter. Okay? That's what a solution is. So in your little box off to the side, go ahead and write this. It says, if x plus 2 is equal to 6, then 4 is the solution. If x plus 2 equals 6, then 4 is the solution. So then right next to it, go ahead and write that, because that would be how it would be expressed. X is equal to 4. That would be how a solution is expressed. Okay. All right, and then our next word or words would be equivalent equations. Everyone? All right, and here's what equivalent equations are. They are two or more equations with the same solution. Two or more equations with the same solution. So in your little box, here's an example of equivalent equations. X plus 3 equals 8. And the other one is 9 is equal to x plus 4. Two completely different equations, but because both of their solutions would be 5 for them to work, that would mean that there are equivalent equations. Okay. Now, here is what I want to talk about. All right, we have a little story time today. All right, so you get to.
Okay.
All right, it's actually not quite a story. It's actually, I guess you could say a story, kind of, but it's nonfiction. It's kind of reminiscing for many of us. All right, so here's what I want to talk about. Okay, as all of you guys know, all right, or you should know. I mean, if you've been here since the start of the year, okay. Before I started to teach, I've taught 7th grade math for a long time. But before that, I was a 6th grade teacher at TK. All right, and at Timber's Country Elementary, we of course would, like many of you guys probably did last year, if you went to a Clovis Unified School, elementary school, you more than likely went to 6th grade camp, all right, in Sonora. All right, and now all schools have a little bit of a different twist to their trip, okay? At TK, and I think a couple people have told me that it's still, at least at TK, is still like this, but when I was a teacher, what we did is meet up in the morning, everyone packed their luggage, and we go in a bus, and we would head up. Well, Sonora's a long ways away, so what we did is that we had a little break, closer, not too far from Sonora, but closer to Sonora. We had a little break, and we stop in this town, and we basically have lunch. Well, this town was a little old gold mining town called Columbia. All right, so how many of you guys remember Columbia? How many of you, okay, and if you either don't remember it or you didn't go to a school, don't worry, I'm going to describe it, and it's not going to matter in the end for you to understand what this story is all about, okay? So, yes, we're all excited about gold mining. So Columbia, if you didn't go, or even if you did and you just kind of forgot about it, at least, and it all depends which school you went, where they stopped and everything else. Well, with TK, we would stop down at the bottom. I say at the bottom because it didn't seem like the bottom, but it's kind of like this park area. And the bus would stop, and we would get out. And a lot of times, it depends on what time we got there. We'd either eat lunch before or after, but we'd eat lunch. A lot of times sack lunches. And then what happens is we'd break up into groups. And all the different groups would take a tour. So for an example, maybe your tour would start there kind of down in that park area, and you would go over and then I do remember that there was this one spot where they had kind of like this hill that was in front of you. And what they did is they showed you that back in the day, they would take like a big hose, right? And they'd hose down the side of this mountain, and it would flush out possible gold flakes out of the hill. Okay? And that was one way of mining. And anyway, that's beside the point. But after they explained a little thing like that, we would walk up this side by the hill there, and we'd walk up and kind of on this dirt trail. And over on the one side, there was, I think, a little gift shop. And we'd come up at the top. And a lot of times, if this is your first time being there, you're a little surprised. But you come out on top, and all of a sudden, as you got up to the top, you were basically almost right in the middle, well, not in smack dab in the middle, but like between two aisles of buildings, and these old buildings, and you were looking right down like a dirt road. And this dirt road, and this is actually the town of Columbia, right? There's a saloon, and there's all these neat things, and these different shops. There's a candy shop there, and but basically all of the buildings themselves were originals, okay? So when you come up, and I don't know if any of you guys remember, when you come up, you look on your left-hand side, and on the left-hand side there was a building, and it was actually a famous, and still is a famous business. Does anyone remember what that business was there? I'll give you a hint. It's a bank.
Yeah.
It was Wells Fargo. It was Wells Fargo. And it doesn't, now there's no ATMs or anything that you just stick your card in. It's pretty old Wells Fargo, right? It's back from the gold mining days. Anyway, here's what I'm getting at. When we would go into Wells Fargo, we would loop around inside of the building as they would give us the tour, and sometimes the small group would stop inside the building there. But the building, what it had it had a you'd walk around and it had like a countertop, and then you had a spot where you didn't go back in that section, right? But it had a countertop, and we'd walk in the doors and go in that front section and loop back out and around. But on that countertop, in a glass case, there was this thing that looked kind of like this. And this is a sketching, so yes, it is going to be a little ugly. All right.
Oh, it's one of those scales.
Okay. Well, it was a scale. And what would happen is they'd probably, if you had a good tour guide, they would tell you about that scale and explain that in the gold mining era, when they would, wash the side of that mountain out or whatever, they would bring up their gold flakes, or gold nuggets if they were lucky, especially during the early times, and they would turn around and they would bring up a bag, and they would they place that bag. Okay, sorry, that doesn't look like a bag. I'm kind of like making a little bow and trying to make it. Okay, that was okay. You get the idea. So there's a bag of gold dust there, and then what they do is they'd come around here, and they would put weights on the other side. And then what would happen is this scale would go up and down on each side, and then finally what they were looking for is that scale, both dishes on each side, right, to be even. What would that say if they were even?
That's wonderful.
It would tell you how much it is.
It would tell you exactly how much gold is in this bag. Okay, how much money they would have to convert it to money, right, and give it. Well, what these little weights were is they were little weights, let's say little grams, and if this would say if there's 5 over here and this was equal to that means that there's 5 grams of gold in this bag. Okay, so they were looking for it to be completely balanced. Okay, so what I want you to realize is what this really is like is this scale here is like having an equal sign, and the equal sign, of course, each dish on each side, okay, that sign is representing that it is balanced on each side. Now we're going to do a little corny little activity, but I want you to stick with me. It's just a few seconds, and it actually gives you guys a chance to get some blood flowing in your legs right now. So what I'd like you to do, if you're in an aisle seat, do me a favor, just hop out in the aisle. If you are in a middle seat, just kind of stand up and kind of give yourself enough space. You might need to stagger out. Now what I'd like you to do is I'd like you to go ahead, and I want you to pretend like your body is this scale and your hands are these dishes. Okay? Now, here's what I want to talk about. Okay? Go ahead and have your hands out. Yes, I know it's corny, but stick with me here. All right? Now, let's just say, for the sake of this story, that every weight that we put on, is going to be exactly the same amount. Okay? We're not going to talk about gold dust. We're just talking about just these different weights. Okay? They're the same size, same weight. All right? So here's what we're going to do. Let's say that we end up putting 5 weights on this side and 5 on this side. Okay? The scale. Well, what's the scale going to do?
Nothing.
Well, probably when you put them on, right? It's doing this sort of thing. But yeah, you're right. In the end, what's going to happen? It's going to balance out. They're going to be even. Okay? Because it will show that there's an equivalency between the two sides. Now, here comes the question. And think about it before you shout it out or you do anything with your arms. What happens if you take 2 of the weights off of this side?
Go down.
Take them off.
And then up.
Be careful. It doesn't go down because it would go up. Because all of a sudden, this side is lighter. Right? Now, here comes the main question. This side here, we just took what off?
2.
2 off. We took 2 off. What do we have to do to this side to get it back balanced?
Take 2 off.
You have to take 2 off. If you do anything else, you have to take 2 off of this side to get it balanced. Now let's say we're taking this side again. We're adding 6 of those weights on this side. What's going to happen? Yeah, all of a sudden there's going to be a lot more weight, right? This thing just does this. Again, what do we need to do to this side to get it balanced again? You add 6 to this side. Here is the bottom line, ladies and gentlemen. With a scale, in the gold rush days, for example, if you were doing that, whatever you do to one side of the scale to keep it balanced, you have to do it to the other. Equations are exactly the same thing. Whatever you do to one side, because they're equal, they're balanced, you have to do to the other. If you don't, then it's not going to be balanced, and you'll get, of course, a wrong answer, in this case, a wrong solution. Okay? All right, so let's go ahead and have a seat. I'll go ahead and relate this a little more to our notes here. So here we go. Sorry. All right, our next word then, or phrase, is subtraction property of equality. Everyone?
Subtraction property of equality.
All right, so subtraction property of equality. Here's what it says. if you subtract the same number from each side of an equation, the two sides remain equal. That's what we just said, right? Mathematicians give it that fancy name, but that's pretty much, you subtract something from one side, you have to subtract something from the other if you want it to remain equal. That's, of course, what we want to do. So, for example, go ahead and write this down. If you have something like 5 equals m, then you could actually do this. 5 minus 2, so you're subtracting 2 off of that side, it would still be equal if you did m minus 2. If you're subtracting 2 from both sides, it would still be equal to each other. All right. Here we go. Our next word, and if you're using common sense, right, this is probably you're gonna probably know what this is, and that is addition property of equality. Everyone?
Addition property of equality.
And this is if you add the same number to each side of an equation, the two sides remain equal. If you add the same number to each side of an equation, the two sides remain equal. Okay? So, very similar. If you have something like 6 is equal to y, it'd still be the same if you add 1. So 6 plus 1 would be equal to y plus 1. Whatever you do to one side, if you do it to the other, the equal sign still remains true. Okay. Question? Not really. Just because technology is. Are you sad about it? You look kind of sad.
Impressed.
Okay. Here we go. All right. So what I'd like you guys to do is that's it for vocab. Go ahead and grab your book. Flip over to page 440. 440. Eyes up here as soon as you're ready. Thank you, those of you who are ready. Page 440. Okay, so here's what I'd like you guys to do. Okay, put your pencils down just for a second. I'm going to do this first one. All right, I just want you to watch. All right, so here's what number 2 is. Okay, I'm going to go ahead and do it up here. On page 440, problem number 2 says 7 is equal to y plus 2. Okay, now listen carefully. I'm going to start by getting this out of the way. What is the answer? What's the solution? 5. It's 5, right? We know it. All right. What we're about to do is not about knowing the answer. What it's about is practicing the process of how to correctly get an answer. Because, guys, this is by far the easiest thing you're going to see when it comes to equations as a 7th grader. It's only going to get harder. And if you don't have the tools, okay, to do it the correct way, then when you get to the harder ones, your little quick way of doing it is not going to work. Okay? So you need to make sure that you practice it the right way from the very beginning this year. Okay? So here's what I'd like you to do. Again, thank you those of you that have pencils down because I only want you watching. Okay? Now, here's what I want. Here's the main reason why I'm wanting you to do this. You're going to see me do all the work that is needed, but you're going to see how fast I do it. And what I'm saying is I'm not trying to impress you with how fast I am. What I'm trying to do is I want you to see how fast you can do it by still showing all of your work. Because the biggest thing people do is, but that's ridiculous. I don't want to spend that much time doing it. All right? And it's not a lot of time at all to get the correct practice in. Okay, so watch. Here we go. The very first thing I'm going to do is I'm going to find my variable because I need to know which side of the equal sign to go to. That's important since a lot of us always go left to right. You can't do that. Okay? With this, find your variable. It's on the right side. So here's what I'm going to do. This number here, the 2 is being added. It's a positive 2, so I'm going to do the opposite there. I'm going to do the same thing on the other side to keep it balanced. Those cancel. I end up with y is equal to 5, and there's my answer. Okay? Not extremely hard. Okay? Pretty easy. But I showed all the work that you need to show on this lesson and talked about it and still got it done in 15 to 20 seconds or even less. Okay? It's not very long. Okay, now they're going to be a little more challenging on here, but not much. All right? Okay, so here's what I want to do. Let's go ahead and do another one. Let's do this one together. Let's do the very next problem. Grab your pencil this time, though. Okay, here we go. Problem number 3 is -7 equals c minus 6. Okay, now let's write the steps. Here we go. Step 1. Find your variable. I want you to box it in. You always have to box them in? No. All right? You won't always have to box them in, but for this lesson, I want you to box it in. Okay? Maybe even for this whole chapter. Okay? So you're going to box in your variable. I need you to identify which side of your variable is on. In this case, it's, again, on the right. Okay? Now, step 2. You're going to take a look at what is next to it. In this case, it is a -6 or a -6. We are going to do what's called the inverse. Okay, and what that is, you could write this down if you want. It's the opposite operation, or the opposite sign. So if this is a -6, I have a +6 here. Now comes step 3, and here's the word I'm going to write, balance. All right, and what all that means is whatever we do to one side, we're going to go ahead and do it to the other side. So I'm going to add 6 here. Okay, now comes step 4, and that is we're going to go ahead and we're going to solve. And to be able to do that, the whole reason why we had a -6 and a +6 is where they could cancel out, and we can what they call isolate the variable, meaning get the variable by itself. Okay? I am going to definitely bring down my equal sign, and I have a -7 plus 6, which gives me a -1. So C is equal to -1. Now you might want to put a little star by step 4, and here's why. Your answer, I want your answer to have the variable and the equal sign. And first of all, the reason is because you're going to get to problems that have more than one variable in them eventually. And the other thing is that we're actually going to see signs that are not equal signs that we're going to use instead of equal signs. So you need to say that this letter here is equal to that. Okay? Okay. Questions about those 4 steps? Okay, so some people will turn around. I am not very picky here in 7th grade about this, but you will end up getting teachers who definitely always want the variable on the left. Now, because it's a balance, right? Think about the balance, right? Let's take a look at this little ugly picture I made, all right? You have your bag here of gold, and you have your 5 stones, right? Well, it's balanced here. What if we put the bag of gold here and your 5 weights over here? Is it different? It's still going to be balanced. And what I mean by that is if you write it, your final solution as C equals -1, it just says the same thing. Okay? It's just flip-flopping around the equal sign but you know, it's like me doing this, right? Like this and like that. Same person, I'd have the same thing on my hands. It would just be flip-flopped. All right? So that kind of gives you that's a great question though, but some teachers eventually will want you to express answers like this. So when you get a teacher like that, make sure you're listening and following directions. A lot of our answer keys will look like that, so just be aware. Not all of them, but a lot of them will. Okay. Any other questions before I have you try one? All right. Go ahead and go to page 443, your homework, problem number 20. Problem number 20. Go. See if you can look on the neighbors. Do it on your piece of paper for now. All right, how many of you need more time? Okay. All right, give you guys about 20 more seconds or so. Okay. Now, listen carefully when you share with your neighbor, okay? You guys can start by sharing your answer to see if they match. But here's what I want you to also do. I want you guys to share your work. When you're looking over your neighbor's work, I want you to make sure that they box in their variable. 3 things. Make sure they box in their variable. Make sure that they show work on both sides. Okay? And make sure that they have their variable and the equal sign in their solution, in their answer. Okay? Guys, if you don't do that on your homework, they'll be marked wrong. So please make sure that you're checking over your neighbors just like that. Okay? All right, 30 seconds. Turn to your neighbor and share. Go.
I got 7. So first I did the opposite sign and subtracted and added -8 plus 8 equals 0. I did the same to the other side, and then I got 7. Then I dropped out the variables and got 7 equals Q.
Alright. I did the opposite for 8. So instead of it being negative or -8, I did positive. And basically the same thing that you did.
Okay, here we go. Problem number 20 was -1 equals Q minus 8. All right, so variables here. Right next to it is -8, so I'm going to go ahead and do the additive inverse. I'm going to do the opposite, add 8 here. Whatever I do to this side, I do to the other side. Add 8 there. So these cancel, so I end up with my Q by itself. -1 plus 8 is a positive 7. You need to use T-charts to use them to be accurate. Okay. Questions? All right, now what I'm going to do is let's go ahead and let's take a look on page 440 at problem number 4. We're going to do this one together. Here we go. What I'm going to talk about is I want to talk about a bar diagram. Now, we briefly talked about bar diagrams in here throughout the year, okay? But they're going to actually ask you to use a bar diagram. So if you take a look at number 4, let's go ahead and close read it together. Here we go. It says Orville and Wilbur Wright made the
First
airplane flights in 1903. Wilbur's flight was 364 feet. This was 120 feet than Orville's flight. Write an
equation
to represent the flight. Use a bar
diagram.
if needed. Then solve to find the length of Orville's flight. Okay, so here we go. For this one, here's what we're going to do. Step 1 is draw a bar diagram. Now, it's not that big of a deal. It's like a candy bar. Realistically, it's a rectangle, a long, skinny rectangle. Okay. Now, here's what you need to remember about a bar diagram. Okay, or let's say a rectangle. This side here, you have to realize, is exactly, for this to be a rectangle, this is exactly the same size as that. Okay? What that represents is whatever we put on top is going to equal what we put on the bottom, because on the bar it's the same length. So after I do that, step 2 is I need to look for the total. Now the total is not always easy to find. Okay? You have to really use some reading comprehension strategies. Now the total here is the length of Wilbur's flight. It's 364 feet. Well, here's why that's the total. Because Orville's flight, its length of flight is going to be compared to it. It's going to be compared to the total, which is Wilbur's. And Wilbur's flight, like I said, I'm going to label it here. From here to here is a length of 364 feet. You don't have to put units on your bar diagram because it's just your work for right now. Okay. Now, step 3 is we are going to place down here what is equal to the 364, which in this case is going to be everything else. And in this case, that everything else, like I said earlier, is Orville's flight, his length of flight. Okay? So what we do know about it is his length. We don't know exactly how long it was, but we do know that it says this was 120 feet longer than Orville. The word this is referring to Wilbur's flight, 364. So what we know is this here is 120 feet longer than Orville. So here's what I'm looking in my head. Maybe this length, and it doesn't have to be exact, but that length of that length is 120 feet, because here to here would be Orville's length, right? Because Orville, if he flew from here to here, he was 120 feet short of Wilbur's total flight. So I could use O for Orville, but then that'd look like a 0. So I'm just going to use X. Now comes step 4. If you build your bar diagram correctly, I just told you guys this bottom is equal to the top. So look at this. The bottom is 120 feet plus whatever Orville's flight was, which we don't know, it's X. And that, like I said a second ago, is equal to the top, which is Wilbur's flight of 364 feet. So all I did was write my equation based off of that. Now comes step 5, and that is solve your equation. I'm not going to go step by step like we did above. All I'm doing is here's a positive X. The 120 is positive, so I'm going to do negative 120 or subtract 120. Whatever we do to one side, we do to the other, so I subtract 120 there. And we end up with X is equal to 244. Now, step 6, and you guys probably already do step 6 automatically, hopefully, but it is a word problem. If I reread it, it says, write an equation, use a bar diagram if needed, then solve to find the length of Orville's flight. Everything, guys, in there was all about feet, so make sure you put your units. 244 feet.